This is going to be a very, very weird unit for me because, Mackie, this could be something that I realize by Wednesday of next week, I'm done because kids remember all the stuff that I taught during Rhyme and during the previews of it from this week, or I teach it for the length of time that I said that I was going to teach it and we move on. I don't know. I'm hoping that enough people paid attention to the stuff that we've already done with conduction, convection, and radiation that I don't have to spend a ton of time on it and we can get into weather a little bit earlier. But I don't know. We'll see how that goes. All right. Heat exchange, conduction, convection, and radiation. And again, this picture is fantastic. I like this convection because that is the hot air rising up above the fire. I wish they would show something like a pot of water boiling, or they would talk about convection cells on the beach with, like, sea breezes and land breezes. But that's another view of convection too that you can show all together. So again, you don't want to touch this rod because the rod is hot. Conduction. Sitting beside the fire is radiation, and the heat above the fire is convection. You can have a hot air balloon because that's convection as well. There are a lot of different examples, and we'll go over those. First thing we're going to talk about, the first thing I'm going to write on my anchor chart as I get that back out and flip it around, is what is heat? Heat is a form of energy. Sound is a form of energy. Electrical energy, mechanical energy, chemical energy, nuclear energy. You don't really have to know any of those, but you do need to know that heat is a form of energy. And we're going to define heat like this. Heat is a form of energy that is transferred between objects with different temperatures. And I'm going to pause that there, write that on the anchor chart, and you're going to get that written down. Heat is a form of energy that is transferred between objects with different temperatures. So we know that heat's a form of energy that's transferred between objects with different temperatures. And again, it has to be objects at different temperatures. You cannot put two things that are 85 degrees each on top of each other and expect any heat to be transferred. There is no movement of heat at that point because there's no heat to be moved. They're the same temperature. Something I wrote down, I put a star beside it because it's one of those things you will see very often. You'll probably see a question about how does heat move. I mean, again, we can't talk about the benchmark, but I wouldn't be shocked if that was on there. Heat flows from warmer objects to cooler objects. Heat flows from warmer objects to cooler objects. So again, we just talked about this in class, but when you're holding ice in your hand, it is pretty easy, Anna, to say, man, this ice is making my hand cold. It's true, but it's not because of what you're thinking. Like, the cold is not moving into your hand. It's because the heat is moving out of your body into the ice that you start to feel cold because you're losing your heat energy. Because that's two objects of different temperatures, right? You are not the same temperature as ice. Maybe Orphelia is right now. I don't know because she keeps saying she's cold. But the rest of us are not the temperature of ice. So if we put ice in our hands or on us, or your mean little brother puts it down your back when you're in the kitchen cooking or something, you feel that coolness because the heat's leaving your body going to the ice. Who remembers this triangle with solid, liquid, gas? And so solid to a liquid is melting, liquid to a solid is freezing. We had sublimation, desublimation, condensation, evaporation. Remember that? Yeah. All of these terms are going to come back around again. As a matter of fact, when I give you your vocabulary sheet, you're going to see some very familiar terms on it. You may even look at the sheet and be like, well, this is going to be a very easy grade. Good. When we take the quiz, probably next Friday, make sure that you're ready for it. I'm not going to make you redraw this because it's in your notes. If you need to find it and redraw it inside of the heat exchange notes, go for it, but we're not going to take time to do that now. Okay, the phases of matter, solid, liquid, and gas. Sublimation, again, deposition or desublimation, same thing. Melting and freezing, condensation, evaporation, all words that we've already seen more than once. We've all seen this picture before too, right? The molecules inside of a solid, liquid, and gas. Can you see how solid, liquid, and gas are really going to tie into this heat exchange unit? Should make it very easy for us, and we should be able to blow through this pretty quickly. I'll come back and watch that later. And we're not going to do that today. Conduction. Conduction is the passing of heat through the material while the material stays in place. So it's the passing of heat through touch, which is what I'm going to write the passing of heat through touch. I'm not writing the material stays in place because that doesn't make a lot of sense in my head. When two things touch and heat passes, its conduction makes sense to me. The passing of heat through touch is conduction. So again, you're a moron. You grab a hot pot off the stove that's like flaming hot and you burn yourself. You just went through conduction. So burning your finger on a hot pan or burning your finger on the stove, conduction. I'm going to jot these on my anchor chart. Examples of conduction. Cooking an egg on the stove, ice melting in your hand, burning your finger on a stove, on a spoon that's in a hot cup of coffee. Do you see that bottom part? Any animal lying on a cool patch of dirt, the heat transfers from their body to the dirt. So that's why elephants do that a lot. You'll see them kind of dig out a big patch of dirt and kind of roll in it. They're trying to get the heat away from their body. Convection. So we know what's coming, right? Conduction, convection, radiation. Convection is the transfer of heat through the movement of a gas, like in the air, or the movement of heat through a liquid. Convection. This is a picture I do need you to get very, very, very familiar with. Jesse, will you see that heat going up and that cold coming down? That is called a convection cell. You will see that in water. If you've ever noticed the macaroni kind of goes in a circle, if you really watch it, it comes to the up and it sinks to the bottom. Comes to the top, sinks to the bottom. That's because the hotter stuff from the bottom is rising and the cooler water at the top, because it's getting cooled off by the air, is sinking. And it does that constant circular motion. When we get to weather, which is right around the corner, this is how heat moves around the earth. Hot air rises, cold air sinks everywhere, especially at the beach. And that's what causes our sea breezes and land breezes. Right? That's how heat moves around the earth. It's through these convection cells. Hot going up, cold coming down. Examples of convection. This might be the one thing that people need to jot down. Boiling an egg in a pot of water. Here's this middle one. The movement of thermal energy around the earth. I think that's more weather, but knowing them, they probably put that on the benchmark, which we'll find out when we get to go over that. Boiling water. Cold water sinks, hot water rises. So hot air rises, cold air sinks, hot water rises, cold water sinks. These are all convection examples. Well, we've had conduction, we've had convection. I would imagine what my next slide would be, unless I just lost my mind when I was making this. Nope, radiation. Transfer of heat through electromagnetic rays. Easy for me to say. The transfer of heat through electromagnetic rays. There is no touch involved. Some good examples of radiation. Obviously, the sun is a huge example, right? And that's how the sun heats the earth. It's certainly not touching the earth. It's not blowing hot air on the earth. It's not dumping hot water on the earth. It is heat waves, radiation. Yes. There, yeah, it takes a very short time if you think about how far the sun is away, but when you're also thinking that light wave, that heat wave took 8 minutes to get here, 8+ minutes, is kind of wild to think about. It's like old when it gets to you. Radiation examples. The two big ones. Sun sitting beside a campfire. Almost every time. 90% of the time, the questions that come from radiation are the sun and getting warm beside a campfire. All right, so we'll watch this heat study jams. If you're at home, you need to watch this as well. We'll come back to this. Here we go. Quick quiz. Again, we're rocking in 87, and this is the first time we've taught it, which is not necessarily true. What shows an example of convection? Well, if I've got convection, I'm looking for heat through gas or heat through water, not burning by touching something, not getting an electric blanket, and not holding the end of the metal rod. That is cooking an egg in a pot of boiling water, which is actually one of our examples if you look at our anchor chart. What best describes heat transfer by radiation? Again, I'm not even looking at the answers. I'm looking for the sun or campfire. Slice of bacon frying in a pan. The bacon's touching the pan, conduction. A pot of stove, boiling water. Were you either talking about the pot touching the stove is conduction, or you're talking about the boiling water, which is convection. There's the campfire, and a hot air balloon, which is convection. That one's a little tough, but not radiation. In what way does the sun warm the earth? Radiation. The end. If you answered condensation, we need to have a conversation. Moving on. We'll watch that later. And we're going to pause. We're just going to stop here because then we're going to start getting to like the whole dual survival, conduction, convection, radiation, and the part of the lesson where we need to go outside. So we're just going to freeze here. Apparently there's a bunch of whiners in the room that I didn't say about clicking notification bells, smashing the like button, and subscribing. I apologize.
Press that.